Stop for a moment. Look at your hands. Look at the ground beneath your feet. For 200,000 years, this was our prison. We were creatures of the dirt, bound by a ruthless law that no prayer and no muscle could break. Gravity. We looked up at the birds, the masters of an invisible ocean, and we felt a jealousy so deep it became mythology. We built wings of wax and feathers. We jumped from towers. We prayed to gods of the wind. And for 200,000 years, the answer was always the same. We fell. But then, in the blink of a cosmic eye, everything changed. Today, right now, at this very second, there are 500,000 people floating 7 miles above the surface of the Earth. They are sitting in comfortable chairs, sipping coffee, watching movies, bored by the absolute miracle happening just outside the window. We have normalized the impossible. We have turned the sky into a highway. But ask yourself, do you actually know how? How does a metal tube weighing nearly 400 tons, heavier than a blue whale, heavier than the Statue of Liberty, convince the thin, invisible air to hold it up? If you think the answer is just wings or engines, you have been told a simplified lie. The reality is a violent, beautiful argument between 4 fundamental forces of the universe, an argument that we are winning. Welcome to the physics of the impossible. To understand how a plane flies, we first have to understand the war being fought on every single atom of the aircraft. It is a tug of war, a stalemate. Imagine the plane suspended in the air. Pulling it down, relentlessly, is weight. Gravity's contract with mass. It is the enemy we must defeat. To fight it, we need an opposing force, something that pushes up with equal violence. We call this lift. Holding us back is drag. The air itself is thick. It resists us. It pushes against the nose, the wings, the windows. To overcome drag, we need thrust, the brute force that propels us forward. The equation of flight is simple. Thrust beats drag, and lift beats weight. Thrust is easy to understand. We just burn fuel to create an explosion out the back. Weight is easy, it's just mass. But the real mystery, the holy grail that puzzled the greatest minds in history for centuries, is lift. How do you generate an upward force from thin air? If you open a high school textbook, you will likely see a diagram. It shows a wing curved on the top and flat on the bottom. The explanation says that because the air has to travel a longer distance over the top, it must speed up to meet the air on the bottom at the same time. I need you to delete that from your memory. It is wrong. It is a myth that refuses to die. There is no law in physics that says air particles separated at the front must reunite at the back, like long-lost lovers holding hands. They don't care about each other. In fact, the air on top moves much faster than the simple explanation suggests. The real answer is far more interesting. It is a centuries-old debate between 2 giants of physics, Isaac Newton and Daniel Bernoulli. For a long time, people argued, is it pressure or is it reaction? The truth? It is both. Let's look at Newton first. His third law states, for every action, there is an equal and opposite reaction. Wings are not just passive shapes slicing through the wind, they are active tools. They are aggressive. As the wing moves through the sky, it is tilted slightly upwards. It crashes into the air molecules and forces them down. It grabs tons of air every second and throws them violently toward the ground. If the wing pushes the air down, the air must push the wing up. That is Newton. It's the same reason you feel your hand being pushed back and up when you stick it out of a moving car window. You are deflecting the wind. But Newton is only half the story. If flight were just about pushing air down, planes would be incredibly inefficient. We need magic. We need Bernoulli. Because of the specific shape of the wing, the airfoil, and the angle at which it cuts the sky, something strange happens to the air flowing over the top. It gets squeezed. It has less room to move. Daniel Bernoulli discovered that as the speed of a fluid increases, its internal pressure decreases. It sounds counterintuitive, but it is the law of nature. The air on top of the wing accelerates to incredible speeds. This creates a zone of low pressure, a partial vacuum, above the wing. Meanwhile, the air below remains at a higher pressure. The high pressure below pushes up, and the low pressure above sucks the wing towards the sky. The plane isn't just riding on a cushion of air, it is being pulled up by the sky itself. But there is a missing piece. Why does the air follow the curve of the wing? Why doesn't it just fly straight off the top and leave a chaotic vacuum? This is the secret sauce, the glue of flight. It is called the Coandă Effect. Fluids, like air and water, have a tendency to stick to curved surfaces. Imagine pouring water from a spoon. The water doesn't fall straight down, it curves around the bottom of the spoon. The air does the same thing. It clings to the wing, hugging the curve, pulling itself down. This stickiness is what allows the wing to bend the airflow so effectively. Without the Coandă Effect, the air would separate, turbulence would take over, the wing would stall, and the plane would fall like a stone. So, we have lift, but lift requires speed. You cannot generate lift if you are standing still. You need to move, and to move something this heavy, you need muscle. Enter the modern jet engine, the High-Bypass Turbofan. It is likely the most reliable, powerful, and complex machine ever built by human hands. Many people think jet engines work like rockets, shooting hot gas out the back to push forward. That was true for the old, loud fighter jets of the past. But modern airliners are different. They are smarter. Look at the front of a Boeing or an Airbus. That massive fan you see, it isn't just for cooling. It is a giant propeller. In a modern engine, about 90% of the air that enters doesn't even go into the engine core. It bypasses the combustion chamber entirely. It flows around the outside. This is called bypass air. This cold air is pushed backward by the giant fan, generating most of the thrust. It cushions the explosive noise of the engine core, making the flight quiet and efficient. Only a small percentage of air goes into the center, the core. There, it is compressed, mixed with fuel, and ignited. This controlled explosion drives the turbines that spin the big fan at the front. It is a self-sustaining cycle of suck, squeeze, bang, and blow. A continuous explosion that pushes us to 600 miles per hour, just under the speed of sound. But having power and lift is not enough. A plane that only goes straight is just a very expensive missile. We need control. A pilot doesn't just turn a plane like a car. They conduct a three-dimensional ballet. To roll left or right, we use ailerons on the wings. One goes up, the other goes down, flipping the lift, rolling the aircraft. To point the nose up or down, we use the elevators on the tail. To yaw left or right, we use the rudder. When you see a plane landing, watch the wings. They come alive. The flaps extend to increase surface area, grabbing every bit of lift possible at slow speeds. The slats open. The spoilers tease the wind. A computer is making thousands of micro adjustments per second, fighting the chaos of the atmosphere to bring you down gently. It is the closest humanity has ever come to building a living, breathing creature. Now, take a step back. Think about what happens when you board a plane. You walk through a tunnel, you sit in a seat, and you close your eyes. You feel a push against your back, a rumble, and then a strange lightness. In that moment, you have left the realm of biology. You have entered the realm of engineering. We were not born with wings. We have heavy bones. We have no feathers. By all the laws of natural selection, we belong on the ground, hunting and gathering in the dirt. But we refused to accept that. We looked at the birds and said, "I want that." We took the invisible air, something we cannot even see, something we cannot hold, and we mastered it. We turned the laws of physics into a ladder to the stars. Flight is more than just transportation. It is the ultimate proof of our stubbornness. It is the proof that with enough curiosity, enough science, and enough courage, gravity is just a suggestion. The next time you are flying, look out the window, look at the clouds below you. Those are the ceilings of our ancestors. They looked up at them and saw gods. You look down at them and see scenery. We have conquered the impossible ocean. We have turned the sky into our home. And the most amazing part? We are just getting started.